Hi, welcome back, Allen High School Pre-AP students. We're talking about models of atomic theory. I'm hoping that it worked out that we had time to do a little mini inquiry in class on the periodic table. So I want to summarize that inquiry, make sure you got the right information that you needed from this. Now, this is how we're going to get our electron configurations. These groups here, and that includes helium, this is called the S block. So all of this is called the S block. All right, and in the S block, the energy level is equal to the period number. So if this is period 1, 2, 3, 4, 5, 6, 7, this is 1s1, 1s2, 2s1, 2s2, 3s1, 3s2, 4s1, 4s2, and so forth. All right. Now, over here, we have the P block. Now, isn't it wonderful? What P has 3 sublevels, right? 3 sublevels can hold 6 electrons. And lo and behold, we have 1, 2, 3, 4, 5, 6. All right? So this is the P block. This is also energy level goes by the period number. So N is also equal to the period number here. So these are 2P, these are 3P, 4P, etc. Okay, we're going to kind of take a walk through this. All right, this is the D block. Now I've got a picture in a little bit that shows the F block coming into play here, but for now we're going to keep that plucked out. This is the D block. In the D block, N is equal to your period number minus 1. So this is period 4, so this is 3D. This is period 5, take away 1 makes that 4D. Period 6, take away 1 makes that 5D and 6D. Okay, so that's, you know, and what? D has 1, 2, 3, 4, 5 orbitals in it. 5 orbitals can hold 10 electrons, and sure enough, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the D block there. So it works out very nicely for us. Now this is the F block. They're plucked out solely so that it's easier to draw on paper and easier to make posters. This is period 6. This is period 7. N is equal to the period number minus 1, or 2, excuse me, minus 2. So 6 minus 2 is 4, so that's 4F. 7 minus 2 is 5, so that's 5F. So that's how we do the periodic table with this. And we're going to just walk through the periodic table. And it'll be taking a walk, always from left to right in this direction. And that's how we'll fill. So this would be 4S. Once we cross this boundary, we're in the 3D block. Then we cross this boundary and we're back in the 4P. And we're just going to keep filling from left to right. Now down here, you can kind of think of it as a cul-de-sac. Actually, we're going to make it easy on you and let you jump there instead. And so you can kind of think of it as a cul-de-sac. So you go around this block and you come right back out. Hit here, hit that boundary. Again, we're going to cheat just a little bit. They do funky things at there. Do this cul-de-sac and come right back around and then pick up your journey. Okay? So I know it seems weird. Seriously, I promise you it's all going to work out as you're doing your practice in class. All right? So let's go on and let me do some examples for you. All right, we're going to start with cobalt. Now, find cobalt on the periodic table, and you'll see that cobalt is element 27, so it has 27 electrons. So we need to put 27 electrons into this orbital diagram, and I notice my S's and my, those are shifted a little bit compared to yours, but it should be okay. So we want to put 1, 2, and then 3, 4, 5, 6, 7. Don't forget Hund's rule. And then Pauli, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 electrons. And that would be cobalts. Now, you can draw this in this direction. Okay, so you could do 1s, 2s, 2p, and so forth. So you can put energy going that direction if you want. Now let's write the electron configuration. It's a shorthand of that orbital diagram. So we've got 1s and there's 2 electrons in it. Then we go to energy level 2, the s sublevel, 2 electrons. Energy level 2, the p sublevel, has 6 electrons. Energy level 3, the s sublevel, has 2 electrons. Energy level 3, the p sublevel, get rid of that 27 there, has 6 electrons. Now, you would think we would go to 3D, but it doesn't. It gets a little mixed up and goes to 4s and put 2 electrons in there. And then we do 3D7. So what I did is I took these and I streamlined that notation to 3D7. I streamlined this to say 2p6. Now, what are the highest energy electrons? Remember, the highest energy electrons were the last ones you were filling. So the 3D7 are the highest energy electrons. What are the outermost electrons? N stays true. Find your highest N value, which in this case is 4, and it's 4s2. And if there were p's, I would count them both, frankly. I'd count 4s2, 4p3 if that's what it was. Okay? So cobalt has 2 valence electrons. Okay, so that's basically what that means. All right, now let's go on. Let's look at one for sulfur. We don't have the ions for that one. That's okay. The transition metals do some weird things. So we will talk about their ion formation a little bit later. So let's do the same thing for sulfur. And we're going to walk the periodic table from left to right. So we go 1s2, and then we would go 2s2, and then you cross the ravine on the periodic table to 2p6. Start back, you're at the third period, the s block, 3s2, and then we would do 3p4. So now I know that sulfur has 2 plus 2 plus 6 plus 2 plus 4 electrons. You can count your electrons that way, so it's 16 electrons. Now, if I want to do an orbital diagram, I'm going to do 1s, 2s. For the p, I need 3 of them, so it'd be 2p. Then I'd have 3s, and then 3p. So 1, 2, 3, 4. Remember Hunt. 1, 2, 3, and then you pair. 4, 5, 6, 7, 8. Remember Hunt. 9, 10, 11, and then just one more. There we go. So 2, 4, 6, 8, 10, 12, and there's our 16. Okay? Now our highest energy electrons are the last we were filling. So that's the last sublevel we were filling. So that'd be the 3p. The 3p electrons are actually a tiny bit higher energy than the 3s. You would think that 3s is equal to 3p. But because of the way electrons are moving around a charge, it's not. The 3s is actually a little bit lower in energy. Now the outermost, I would count both of them. 3s2, 3p4. So that gives sulfur in group 16 6 valence electrons. Since sulfur's a nonmetal, nonmetals are winners, and it needs to gain 2 electrons to be like the nearest noble gas. You would expect it to be a -2 anion. So its new electron configuration, you just put those 2 electrons right into the electron configuration. 3p. Now, instead of 3p4, we've added 2 electrons. So the sulfur 2 minus, notice I put the number before the charge, the S2 minus would have the same electron configuration as argon, the nearest noble gas. Now in this case, the radius of S2 minus is greater than the radius of sulfur, and the noble gas that it's isoelectronic with is argon. Okay? So, wow, that's a lot. And hopefully that helps you. I think I'm not going to do another example for you because I think between that example and what we do in class, you'll be good with the electron configuration. So we just have one more model. I'll do it in the next video. So until I see you again, this is, as always, YBCT, your beloved chemistry teacher. Love you guys. Bye-bye.